Hey guys, modern data-driven and AI-powered applications need a robust mechanism to store and retrieve data efficiently. Now, why this is important for any developer or AI, ML, or a data engineer? Because it enables advanced tasks like NLP, recommendation systems, computer vision, data analysis, providing faster processing, scalability, and versatility in building innovative solutions. So today, through a simple tutorial, we're gonna see how this setup can help us retrieve the contextually relevant information or chunk for any user query. So as you can see the setup, the diagram here, we have the custom data ready, that is through the documents that we have, which gets converted into vector embeddings through an embedding model. I'm using OpenAI's embedding model, and these embedding models are stored in a vector database like single store. And basically, we are using LangChain. LangChain is basically an open source AI framework to help you build LLM powered applications. LangChain has all these connectors where you can connect with different vector stores, different tools. Basically, it provides a toolkit to help you build LLM powered applications. So that's what we are using. And so that for any user query, when a user query comes in, it goes through our vector store, that is single store, where all our vector embedding, all our data is present. And through this vector search methodology, it basically retrieves the most relevant chunk, and the that's how the response generation usually happens. So let's say the simple tutorial and yeah, as you can see, here is a simple tutorial of storing and querying vector data using similarity search or vector search. So the tech stack used here is basically single store. Single store is SQL database, SQL database. It started supporting vector storage long back in 2017 itself. It's all-in-one data platform, I can say, and we are using LangChain. LangChain is basically an open source AI framework to help you build LLM powered applications. And we are using OpenAI to basically as our embedding model to convert our data into vector embeddings. So first things first, I'm using single source notebook feature. That's where the code is running. So before starting with the code, make sure you have created a workspace and a database. So how you can do that? Go to singlestore.com, sign up, and single store has a free share tier. You can use it for free forever and until you lose out of all your credits. So go to singlestore.com. Uh, once you go to singlestore.com, you sign up and sign in. This is where you will land. So go to deployments, and by default, I believe you will have your workspace ready. If you don't have a workspace, create one by create a workspace button. And then, like we said, under your workspace, you need to have the database. Creating a database under your workspace is again very easy. Create a just by clicking a button, and I already have my database ready, that is sample DB under my workspace. So make sure you know the name of your workspace and the database you created. Okay, so let's go back to our tutorial. So yeah, once you land here on your tutorial, select your workspace that you created or that has already been created, and uh, select your database that you created. Okay, now let's get started. So we'll install LangChain, okay, and single store DB Python connector through pip install. That's what we are doing. And we are using, like I said, OpenAI embeddings. So mention your OpenAI key, and we are importing everything here. And then let's load some artificial data, right? This is the data we are loading basically. It's a very simple data which has a document, page content, and also the metadata. Okay, so we are loading this data, and once that we are storing the this data in our vector database. Okay, so for that you need to have your single store DB URL. Basically, you need to have the username, password, host URL. 3306 port name, it's by default, it's always the same. And also you need to know the database name. Database name you already know. It is sample DB. Just write it there. And how to get these three, username, password, and host? Let me show you how. So go to this deployment tab, right? So once you go here, on your workspace, you can see the connect button, right? Connect. You can go to SQL ID. As you can see here, once you go to SQL IDE, SQL Pro, you can see. So this is the port. Username is admin, and password. Here is the host URL. Use copy this host URL because we need that. You need to add it here, host URL. Okay, and username you got to know admin, or you can change it whatever you want. And the password is from where you can get the password, right? Password you can get from your access tab, right? There is a password button. Username also you can change. So uh, that's how you can get this URL. And then we need to have a table to load our vector data, right? So we are creating a table name that is PAVTAB. You can change it. I'm just creating it Pav tab. And basically we are storing the vector data in our database. So we did that. Now all our data is present in our database. Our database name is sampledb and the table name is cloud. Let's see if that data has been uh, is already there. Okay, so let's go to deployments. Let's go to database and let's search for sampledb, right? And pavtb. That was our table name. Let's see the sample data. See, all our data has been already stored. We loaded our data in our vector database through a simple, we created that table out tab. You can create your own. So after that, let's ask a query, right? And the query is trees in a trees in the snow using similarity search methodology, all right? So we're gonna see the result. So trees in the snow. As you can see, the response is in the urban landscape, snow descended. So it actually picked from this trees in the snow. Yeah, from here. It talks about basically it is giving you the contextually relevant response, right? Using the vector search or similarity search methodology. So you can ask one more like, what is it? Trees, branches. A single store DB elevates search capabilities by enabling users to enhance and refine search results through, using filters. Metadata fields also you can use, and this metadata field, as you can see, category is no. So we have this category here category as no. So we are basically telling it, hey, in these categories only we want the information, right? Retrieve from there itself. That's what we can do. We can add that filter also. And then if our query is like trees branches, it's gonna uh, retrieve back the contextually relevant response back to the user. So blanketing the countryside in a soft, all that. So trees, branches, blanketing. You can see it's here. Right? And we also told metadata snow. So that's how you can basically retrieve the contextually relevant data using similarity search, vector search. And yeah, using single store, queries can be executed with remarkable speed, enabling swift retrieval of relevant data. So I'm gonna share I have the repo ready. You just need to just copy paste this, try to understand how this whole thing works, storing and querying vector data using similarity search. I'm gonna share this in the description so that you can go and try this out. Thanks.